Okay, so we are going to prove two basic truths about angles and triangles. The conjecture is that the sum of the angles in a triangle is 180 degrees. We're going to prove that using the diagram below. So the sum of the angles would be angle Q plus S plus T, right? So our conjecture is Q plus S plus T is equal to 180 degrees. We're going to label what we've got here. So I'm putting a point A, B, and C on this line, and D and E on that line. Okay, so it says label all the appropriate angles before starting the proof. Also, sometimes what you might want to do in order to see things is you might want to extend the lines a bit. And sometimes that just helps in seeing transversals, right? So we've got this line here and this line here. Those are transversals, and this line is parallel to this line, right? And that's given to us. Okay, so the statement we're going to make is that AC is parallel to DE, and the justification is that that's given, right? We are given that we have a pair of parallel lines. Okay. Now, given that lines are parallel, we can then make all sorts of statements about parallel lines, right? We know that alternate interior angles are equal. We know that interior angles on the same side of the transversal are supplementary, and so on, right? So given that lines are parallel, we have all of those statements we can make, which we did like on the first day. Okay, so you can look back and say, all right, I can use any of those statements, right? If we are supposed to prove lines are parallel, then we have to make statements about the angles that we have. Okay, so back to this. Given the lines are parallel, we can then make statements like, okay, so here I've got a transversal running through BE, and there's an interior angle R, and it's going to be equal to angle T. Right? So we can say R is equal to T, right? Because they are alternate interior angles. Okay, so the reason, right? Alternate interior angles. Because we know the lines are parallel, we then get to use any of the parallel line, theorems, right? Alternate interior angles are equal. We also have angle P and angle S. Okay, and again, remember, this line extends, right? And sometimes it's helpful to sort of just draw the line in. I'm going to draw it in a little more explicitly this time. Look, there's a line, right? So that I can see, hey, these are parallel lines, and this is an interior angle, and so is this, right? And it's the alternate interior angle. So we can say P is equal to S. Also, alternate interior angles. Now, we know that angles P, Q, and R make up a straight line. So what can we say about P plus Q plus R? Yeah, they're supplementary, right? They add up to 180. Well, in a sense, really not supplementary generally refers to two angles, right? So this angle is supplementary. But we can say P plus Q plus R is equal to 180 degrees because it makes up a straight line, right? That's a straight line which has an angle measure of 180 degrees. Okay, but what's angle P equal to? S. And what's angle R equal to? T. So we can say Q plus, now instead of P I can write S, and instead of R I can write T. So Q plus S plus T is 180 degrees by substitution. And then the conclusion is, well, that's what we wanted to prove, right? We wanted to prove the sum of the angles in a triangle, which was QST, is equal to 180 degrees. So let's just throw a little therefore on this, right? Therefore, Q plus S plus T is equal to 180 degrees. And we've shown what we're trying to prove, right? The angles in a triangle add up to 180. Okay. Clear? Make sure you've got that all written down. If you need to look at it again and just think about it, right? And if you want to later, you come up and ask questions and just say, I'm not really sure about why something, why one of these statements, right? So I need to give you a justification, and you need to understand the justification, right? Or be able to come up with your own justification. Oops, I think there was something else on here. Conjecture. The measure of the exterior angle of a triangle is equal to the sum of the measures of the non-adjacent. Okay, exterior angle of a triangle, that's going to be angle A. Okay, let's throw this in. We'll call this B, we'll call this C, we'll call this D. So the conjecture is that angle A, conjecture A, the exterior, is equal to the sum of the non-adjacent. So notice, B is beside A. It's adjacent. So it's the sum of the non-adjacent. So the conjecture is that A is equal to C plus D. Right? That angle A, this exterior angle, is equal to the sum of the non-adjacent, not beside it, right, which is C plus D. Okay. Bless you. So, what do we know about the angles in a triangle? So, B plus C plus D is equal to 180 degrees. And what's the reason? Yeah, that's not really a straight line. Yeah. We just proved it up above, right? So, the sum of the angles in a triangle is 180 degrees. It's called the Triangle Sum Theorem. Right? Triangle Sum Theorem says the sum of the angles in a triangle is 180. We're not putting any special name on it right now, right? But if you did, that's the name you'd put on it, the Triangle Sum Theorem. Sum of the angles in a triangle is 180. Okay, what else is 180 here? You're going a little too far. A and B.
A minus.
So A plus B is 180, right? Straight line. Okay, so those are supplementary angles, or that's a straight line, right? Straight line. Okay, so we know that A plus B is 180. We know that B plus C plus D is 180. Yeah, so what can we say? Not A. So these two guys are the same. So what can you say about this and these?
A equals C plus D.
Yeah, A is equal to C plus D, right? If B plus C plus D is 180 and A plus B is 180, then A must be equal to C plus D. Okay? And that's the transitive theorem, right? So A is equal to C plus D. Transitive. Well, that's what we wanted to show, right? So let's toss in a little therefore. So therefore A is equal to C plus D, right? A plus B is 180. B plus C plus D is 180. That means that A has to be the same as C plus D, right? Something added to B is 180, and it's either A or it's C plus D. So therefore A is equal to C plus D. That's transitive, right? So we have shown that A is equal to C plus D. Okay, and that's what we wanted to show, that the exterior angle is equal to the sum of the non-adjacent, so not the B, but C plus D. Right? The reason is, hey, these three angles add to 180, but these two angles add to 180, so this is the same as that. And I think that's all we need on the page. too far. Okay, determine the measures of angle NMO. I'm going to have to shrink this a bit. All right. Yeah. Let's take the size down. View, zoom. Let's go to 200. Nope, too big. View. 150. Yeah, still a little bit too big. 125. There we go. Determine the measure of angle NMO. So I want to show that one, right? NMO, that's this inside angle here. So let's just say we're doing that with a little one arc. Angle MNO. So I'm going to show that with two arcs. And angle QMO. I'm going to show that with three arcs. Right? And maybe instead of using arcs, we should label them like A, B, and C or something, right? That might be a bit easier. So let's do that. So angle NMO, we're going to call A. Angle MNO, we'll call B. And angle QMO, we'll call C. Okay, so what we want to do is figure out what they are. We want to give some reasons, right? We're not asked to really prove it, right? We're not doing a statement justification. But, you know, we need to show some work. So we need to at least keep in our heads, this is why I'm doing this, right? Or this is what allows me to say such a thing. Okay, so what things can we say from this? So here, let me write something up. So I could say 67 degrees plus A plus C is equal to what? 180. Okay, why?
Because that forms a triangle.
There is no triangle. It's a straight line. Okay, it's a straight line. Okay, what else can I say? I could say that
A plus B plus 39.
yeah, A plus B plus 39 degrees is 180, and what's the reason? Triangle sum, right? Okay, so you know, let's just say we're writing these down for our own sake, right? So that's a straight line. This is triangle sum. Okay, what else can we say? Who? Well, do you want me to label something else in there? I can label something else.
67 equals MNP.
67 equals MNP. What's another way to say MNP? You could say B plus 20, right?
Yeah.
Okay.
I guess.
So so B plus 20 degrees is equal to 67 degrees. Okay, what's your reason?
There's the alternate
interior, right? So we have, right, we're given that LQ is parallel to NP, right? This mark shows they're parallel. So then we have alternate interior angles, right? This angle here is equal to B plus 20, right? That's alternate interior. So if B plus 20 is 67, then what can we say? So what's B equal to?
47.
Right. Okay, so B is 47. Right, so there, we cracked the nut, right? Because now we can figure out A, right? We know that A plus B plus 39 is 180. So A plus B plus 39 is 180. And we know that B is 47 degrees now, plus 39 degrees is 180. 47 plus 39 is what? 86? 96?
94.
What?
What'd you say?
47 plus 39.
Oh, sorry. It's 86.
86. Yeah, you're jumping ahead. So A plus 86 is 180, so what's A? Okay, so A is 94, right? So here, let's put little boxes, right? That's what we need to know. Okay, and what's left to figure out? C. Okay, what do we know? Well, we know that 67 degrees plus A plus C is 180 degrees. So 67 degrees plus 94 degrees plus C is 180. Okay, 67 plus 94 is? 161. So angle C is 19 degrees. Okay, put a little box around that because that's what we needed to show. Okay, so the second set of reasoning, we're not asked to justify, right? But we are asked to determine, which means we got to show some work. So we start off by labeling the diagram, right? And then we start thinking, okay, well, what do we know here? Well, okay, we know that those three angles, 67 plus A plus C, equals 180 because it's a straight line, right? You weren't asked to justify it, so you can just write 67 plus A plus C is 180, but in your head, you're justifying it, right? Any statement you make, you should be able to justify. And what else? Well, we know the angles in the triangle, so A plus B plus 39, that's, equal to 180. Okay. And what else? Well, we've got this alternate interior angle thing going on there, right? We've got the 67 and the B plus 20. Okay. And that's the last thing where we're really making a statement, right? So a straight line, triangle sum, and alternate interior. And we get B, and then we go back up here and we get A, and then we get to go back up here and we get C. Okay. So you'll be asked to do questions like these. Keep in mind just the reason why you're making the statements that you're making, right? So there will be some stuff where you have to do formal proof, right? We got to give statement and justification, and there will be other ones that just say, what are the angles, right? Determine the angles. Okay. You might have to show some work, and there might be ones that just say state. And if you're just stating stuff, then you don't have to. Okay, in the diagram above, if MR is parallel to QP, okay, diagram above, if MR, okay, so this is parallel to this. So let's put on 2. Okay, so we've already used one arrow to indicate parallelness. Now we've got another arrow, right? Which means that these lines now become transversals, right? And again, you may want to extend lines. Right? It's kind of more obvious this is a transversal if you extend the lines out a bit, right? Same thing on this side. Okay, and same thing here, and here. Okay, sometimes it helps. It helps you to see alternate interior angles or whatever else, right? Okay, what do they want us to find? MQO. So we've used ABC. So let's call that D. MQO is angle D. OPN. OPN. So let's call that E. NOP. NOP. So let's call that F. F. MOQ. MOQ. Let's call that G. And RNP. RNP. So let's call that H. Okay, let's mark that in there. Okay, where do you want to start? D, E, F, G, or H? D? Okay. What's D and why? Okay, or can you get D directly, or do we have to go through some calculations together? So if you want to start with D, you got to give me either the angle and then reason why, or something that's going to lead to us getting it. What was the easiest one?
F.
F. Okay, what's F? So, okay, let me ask you this. Can you get any of them directly? Can you just look at that and say, oh, well, this is this because of this? Right? Is there anything you can get where you could just say, all right, this angle is this because, and give me a reason why? Or do we have to go through more of the calculations we've already gone through?
We'll do instead. No, sorry. No, yeah. Can we do G instead?
Do who?
G.
G. Sure. What's G? Huh?
Or sorry, it's A.
G is equal to A. Why?
Interior.
Okay. So, everybody agree? I got these parallel lines, I got a transversal. This is inside, this is here, so A is equal to G, right? Okay. So, what was A? 94. So, what's G? 94. Okay, that's alternate interior. Okay, so maybe we label these guys, right? Let's put on 94 degrees. I mean, it might help if we can see them. What's B is 47 degrees. This is 94 degrees.
47.
What else?
47 is F.
47 is F. Why?
They're opposite.
Yeah, or these three angles add up to, so is that true? What's 94 plus 39?
133.
133, 140, 180, right? So you've got two reasons there, right? Now, I don't know if you should say determine so much as it should just say state, right? Because what we're doing is just sort of cascading through this, right? Like as soon as you got that's 94, that's 47. Why? Well, there's a couple reasons, right? I mean, these are 94 because that's alternate interior. That's 47 because they're alternate interior. Or that's 94 because they're alternate interior. And then these add to 180. Or that's 47 because they're alternate interior. And then these three add to 180. Okay. So what was that anyway? So we had G, F is 47. Okay, what's next?
D is 67.
D is 67. Why is D 67?
Because C plus G plus D equals
Oh, we didn't label C. What was C?
19.
8, was it? 19. Right, 19. Okay, yeah, so this gives us a 19 and 94 and D. These have to add to 180. Okay, so what did you say D was? 67 degrees, right? It's also corresponding angles, right? So we're up to the left of the parallel line and below the transversal. In this case, this is the transversal. Okay. So they're corresponding angles, right? So what was that? D. D was 67. Okay, what else?
You have to think we're at like 47 plus.
We got F, so you're talking about E.
Yeah.
So what's E?
113.
113. Okay, reason?
You go 180 minus 67.
180 minus 67.
113.
Okay,
20 plus E is F.
so what was that? E, 113. And what's H?
113.
Okay, you got a lot of reasons, right? This is the exterior angle, which is equal to the, oh no, sorry, never mind. So it's just this makes a straight line, and we got 67, and that's 113. Okay, or these are alternate interior angles. Okay, so we're done. So that's what you're gonna have to do on a test, only correctly, right? So you just, but same idea, right? It's just you're going through some process. So don't get, if you get A, B, and C wrong, any one of A, B, and C, everything's wrong, right? You get anything wrong with A, B, and C, then the whole thing is just sort of garbage, right? It's just like, yeah, you didn't get any of them. Okay, so how do you check that, right? Well, if you add up any of the angles inside the triangle and you don't get 180, you know you made a mistake, right? So at least be consistent. So that's what I'll start checking for, right? It's like, yeah, okay, this is all wrong, but do these angles add to 180? Do these angles add to 180? And if they don't, then it's just so, yeah, not only is it wrong, but you didn't even bother looking to see if it was right. You didn't bother adding up the angles in a triangle to see if they were 180. Okay, and you've got 3 triangles here, right? One triangle here, and one triangle here, you got one triangle here. So if these angles add to 180 and these angles add to 180 and these angles add to 180, then even if you're wrong, at least you got something going for you and you can get some part marks, right? But if these don't add to 180 and these don't, you get 0, right? It's like, yeah, sorry. You know, you don't even have the angles in the triangle, right? So, okay. In the triangle below, MP bisects. What does bisecting do? Cuts it in half. So angle MP bisects angle NMO. Okay, so if this is A, then this is A, right? Cuts it in half. So these two guys are equal to each other, right? So let's label them. And NQ bisects, cuts in half. So let's label this B and this B. If angle NMO, where's angle NMO? Or what's the angle? So have I labeled it? What can we say here?
The whole thing.
The whole thing. So what's A?
Half of it.
Okay, what's NMO? Twice A. But it sets. So what's A?
15.
15, right? Okay, so all we're doing is working with what we've got here, right? We just labeled. We said these guys are equal, and they add up to 30. Okay, what else? Angle ONM is 116. So what do we know? Then B is 58, right? So that's 58 degrees. Okay, determine all the angles. Okay, where do you want to start? Let's start here. Okay, so what do we know? What's that angle? Okay, so we got to go 180 minus 15 plus 58, right? We know those that. So you go 180 minus 15, enter, minus 58, enter, or minus bracket 15 plus 15. 107?
Yeah.
Okay, so 107 degrees. Okay, what's this angle? Because vertically opposite angles. Okay, what's this angle? So that's going to be 73 degrees, right? Because they add up to 180. Okay, what's this angle?
73 plus 15 minus 180.
Right, so 73 plus 15 is 78. That's 98 minus 1 would be 82, right?
92.
92. Okay, is that right? So what do we got? 95, yeah, okay. This is not a triangle here, but what's this angle here?
92.
Okay, 92, which would be 88? Okay, what else do we got? So this must be 73 degrees for any number of reasons, right? It's vertically opposite, or these guys make a straight line. So I got 73, 58. So what's this going to be here? So we're going to have to add 73 and 58, right? And subtract that from 180. That'll give us this angle. How much? 49. I'm trusting you here, so if somebody disagrees. Yep. It's vertically opposite angles. Okay. So when you have two angles making an X, these guys are equal to these guys. Or 107 plus 73, because this makes a straight line. Okay, so two reasons, right? Okay, what else? Well, we can get this angle here, right? It's 180 minus 49, so that's what, 131? And then we've got this big triangle right here. So I've got this angle's 30, and this is 116, so that's 146. So what's that angle? 34. Okay. Or these angles have to add to 360, right? Angles in a quadrilateral add, but we don't necessarily know that, but okay. So there you go, right? So everybody follow the reasoning, right? There's a lot of vertically opposite angles. There's a lot of, oh, well, okay, it's a bisecting, it cuts it in half. So, you know, all we're doing is just working our way through, right? Hopefully with the calculator. Saying, oh, this adds to 180 and that adds to 180.